So today I'll be teaching about optimization on economic applications. So in order to understand this lesson, we need to understand the basic definitions. First, CX is the cost, which is the amount of money spent to produce X units. So X could be a specific product like books or cell phone or anything. RX is the revenue, which is the amount of money collected from selling the product. So it is also X amount of units. PX, which is the profit, is the difference between revenue and cost to produce and sell X. So from this understanding, we can know that PX is equal to RX minus CX in order to get the profit. So marginal, the basic definition of marginal is that it is rate of change in cost and revenue and profit. We can find these from the marginal as in economics, and it is all due respect to the number of X units produced. So there's two things, marginal cost and marginal profits. So what's marginal profit? It is the rate of change uh, and X in cost to produce X units. And on the other hand, marginal profit, it is the net income per unit after the production and selling process X unit. So next, profit. The profit depends on the number of X units sold. So what this means is that profit, basically, profit is depending on the X units, which is the amount of product. So let's say if there's 10 units sold, that means with 10 units sold, 1 unit is $1, we'll make a profit of $10. So demand function is PX, which is small letter. It's quite different from profit. Profit logo symbol is capital P, but demand function is small p. It's the price per unit that should be charged to sell X units. So the revenue function is Rx equals Px, which is the demand function with X units. X units as in the amount of number. So what is marginal profit? It is the additional profit derived from producing one more unit only for the commodity. So as you can see in the example, let's say if a company's marginal profit production level is 100 units, the profit to be gained for the next amount would be 101 units. You just add one, because as we know, extra one more unit for the commodity. We can use derivative to find the marginal profit, also known as one more extra unit. I'll explain this later more in the next slide. So practice example. The cost of producing X units of book is CX, which is the cost in $1,000, where equation given CX equals x power of 3 minus 20x power of 2 plus 179x plus 242. There's the equation. And the average cost equation is AX equals CX divided by X. This will give us the average. So we want to identify the level of production to minimize the average cost if the business has agreed to produce between 3 and 15 units of book. First, so the steps to do this is, first we have to plug in the CX into the average cost equation. Like here we can see AX equals, this is the CX divided by X. So we simplify this, it'll give us x power of 2 minus 20x plus 179 plus 242 divided by 3. We have to write the limitations as well. Do not forget this. Next, we need to find the critical points by setting a prime x equals to 0. So we derive this, as you can see here, it's being derived already. There will be lesson notes how to derive equations. So this equals 0, which is basically 2x minus 20 minus 242 divided by x power of 2 equals 0. So this is continuing the previous slides. So next step is this one. Once we have this equation, we have to multiply this x power of 2. So it's basic algebra we're doing here. So it will become 2x power of 3 minus 20x power of 2 minus 242 equals 0. So we collect the like terms and stuff, and we factor this 2 out, and we simplify it inside here. It'll give us 2 bracket x minus 11 bracket x power of 2 plus x plus 11. So the critical point will be 11, as x power of 2 plus x plus 11 would give us 0 in this case. So the endpoints, as we know, it's 3 and 15, as you can see here, between 3 and 15 units of book. So we have 3 x's right now. The last step is to plug in the critical points and the endpoint into average equation. So as you can see here, A3 would be equals to 208.7. Remember, we plugging in this into the original AX equation, not the derived equation. And so forth. A11 is 102, A15 is 120.3. So in order to minimize the average cost, they should produce 11 books, as this is the most optimal way I see. So next, let's see if you understand the concept or not. This example. Spritzer Company estimates that when X in 100 units water bottles are produced, the profit will be Px equals negative 0.0035x power of 3 plus 0.07x power of 2 plus 25x minus $200 in thousand. So there's 3 ABC. We'll go through A first. Determine the marginal profit equation. This is pretty straightforward. We just derive the Px equation, which will give us negative 0.0105x power of 2 plus 0.14x plus 25. Next, approximate the profit gain from increasing production from 10 to 11 units, 50 to 51 units, 80 to 81 units. This is all in hundreds. So we plug in all these numbers, 10, 50, and 100, into the Px derived. So it will give us 25.35, 5.75, and negative 31, each of these. Next, we do C. Use the result to suggest the best option. So we can see that when production is 50, there is still profit. However, it's getting closer to 0. So we go back to the previous one. As we can see here, 50, it is getting 50 and 80. It's between zeros, right? So we can tell that it is going closer to 0. So we plug in 0, we make the equation equals 0, which will give us, we use quadratic formula, which will give us 2 x's. One is negative 42.6, one is 55.9. Negative 42 is not considered, it's not, we shouldn't consider this because we're doing economics here, so you should choose the positive among. So from this, thus, we can tell that producing more than 55 units, 100 units will not make us profit as it will become zero. So spritzer companies should maintain the production level between 50 to 5500 units. So this will give spritzer company maintain between the profit. So this is how you do economics in optimization. And thank you for listening. Do the homework questions and assess, and you'll be fine with the assessments.